Space exploration has captivated human imagination for centuries. The stars have always served as a beacon for our curiosity, symbolizing both mystery and the potential for infinite discovery. From the early astronomers peering through rudimentary telescopes to modern-day rovers on Mars, humanity's journey into the vast expanse of space has been a tale of incredible ambition, scientific breakthroughs, and international cooperation. This journey through the history of space exploration takes us from ancient observations of the stars to the fierce rivalry of the space race and the ongoing pursuit of discovering life beyond Earth. What was once confined to the realm of imagination and science fiction has transformed into a groundbreaking reality, continuously expanding the limits of human achievement. Human fascination with the heavens dates back to ancient civilizations. The Egyptians, Babylonians, and Greeks all made significant contributions to understanding the night sky. The Babylonians, for instance, created one of the earliest known star catalogs around 1000 BCE. Ancient philosophers like Aristotle and Ptolemy constructed models of the universe, with the Earth at the center. These models, while incorrect, spurred further inquiry into the nature of the cosmos. One of the key turning points came in the 16th century, with the work of astronomers like Nicholas Copernicus. Copernicus proposed the heliocentric theory, suggesting that the Earth and other planets revolve around the Sun. His ideas challenged the long-held geocentric model and laid the groundwork for future space exploration. This was followed by the groundbreaking work of Johannes Kepler, who formulated the laws of planetary motion, and Galileo Galilei, who in 1609 used a telescope to observe the moons of Jupiter and the phases of Venus, providing strong evidence for the heliocentric model. Despite the scientific progress made in the early centuries, the true birth of space exploration did not come until the 20th century. The development of rocketry provided the critical technology needed to break free of Earth's atmosphere. Early rocket pioneers such as Konstantin Tsiolkovsky in Russia, Robert Goddard in the United States, and Hermann Oberth in Germany laid the foundation for space travel. Their work was instrumental in developing the principles of propulsion and rocket design. Tsiolkovsky, often considered the father of astronautics, was the first to propose the use of rockets to reach outer space. His famous equation for rocket propulsion is still a fundamental concept in space travel. Meanwhile, Goddard's successful launch of the first liquid-fueled rocket in 1926 marked a major milestone. However, it was not until the horrors of World War II that rocketry truly advanced. The development of the V-2 rocket by Nazi Germany, under the leadership of Wernher von Braun, demonstrated the destructive power of rocket technology. After the war, von Braun and many of his team members were brought to the United States and the Soviet Union to help develop their space programs. The post-World War II era was marked by intense competition between the United States and the Soviet Union. This rivalry extended into space exploration and was a defining aspect of the Cold War. Both superpowers sought to demonstrate their technological and ideological superiority, leading to what became known as the space race. In 1957, the Soviet Union stunned the world by launching Sputnik 1, the first artificial satellite, into orbit. This event not only marked the beginning of the space age, but also triggered widespread fear in the United States, which felt it was falling behind in the race for technological dominance. The launch of Sputnik 1 led to the establishment of NASA in 1958, which became the focal point of U.S. space exploration efforts. The space race saw rapid technological advancements. In 1961, Soviet cosmonaut Yuri Gagarin became the first human to travel into space aboard Vostok 1. Gagarin's successful mission represented a significant achievement for the Soviet Union and propelled them to the forefront of space exploration. However, the United States quickly responded. In 1962, President John F. Kennedy announced the ambitious goal of landing a man on the moon and returning him safely to Earth before the end of the decade. The Apollo program, launched by NASA in 1961, aimed to achieve President Kennedy's vision. The program faced numerous technical and financial challenges, But after nearly a decade of hard work, the United States succeeded in landing humans on the moon. On July 20th, 1969, astronaut Neil Armstrong became the first person to step onto the lunar surface, uttering the iconic words, "That's one small step for a man, one giant leap for mankind." The Apollo 11 mission was a culmination of years of research, development, and international collaboration. Armstrong, along with his fellow astronaut Buzz Aldrin, spent about 2.5 hours on the moon's surface, collecting samples, taking photographs, and setting up scientific experiments. The achievement was not only a technological triumph, but also a symbol of human ingenuity, determination, and the ability to reach for the stars. The success of Apollo 11 was followed by several more Apollo missions, with Apollo 17 in 1972 being the final crewed mission to the moon. During the Apollo program, significant scientific advancements were made, including a deeper understanding of the moon's geology and the development of technologies that would lay the foundation for future space exploration. After the Apollo program, the focus of space exploration shifted toward the development of long-term space stations and reusable spacecraft. In 1973, the Soviet Union launched Salyut-1, the first space station, marking a new phase in space exploration. The United States followed suit with the launch of Skylab in 1973, a space station that hosted several crewed missions before it was deorbited in 1974. The real breakthrough in reusable spacecraft came in 1981 with the launch of NASA's Space Shuttle program. The first space shuttle, Columbia, made its maiden flight on April 12, 1981, and marked the beginning of an era of regular access to low Earth orbit. The space shuttle allowed astronauts to deploy satellites, conduct scientific experiments, and even assemble large structures in space. The shuttle program lasted for 30 years and was instrumental in the construction of the International Space Station, or ISS, a joint project between NASA, Russia, Europe, Japan, and Canada. The ISS became a symbol of international cooperation in space exploration. Launched in 1998, it has served as a laboratory for scientific research in microgravity and has been continuously inhabited by rotating crews of astronauts. The station has contributed to advancements in biology, physics, and medicine, and it serves as a crucial stepping stone for future missions to the Moon, Mars, and beyond. While the Moon remains a significant milestone in space exploration, Mars has long been the focal point of humanity's interest beyond Earth. For decades, scientists have speculated about the possibility of life on Mars, sparking numerous missions to study the red planet. NASA's Viking program in the 1970s provided the first detailed observations of Mars, with the Viking 1 and Viking 2 landers sending back high-resolution images of the Martian surface. However, it was the successful landing of NASA's Pathfinder mission in 1997, with the accompanying Sojourner rover, that marked the beginning of a new era of robotic exploration of Mars. Since then, numerous robotic missions have been launched to Mars, including the Spirit and Opportunity rovers, which explored the planet's surface for over a decade, and more recently, Curiosity and Perseverance. These rovers have provided invaluable data on the planet's geology, climate, and potential for past life. The Perseverance rover, which landed on Mars in 2021, is tasked with collecting soil samples that may one day be returned to Earth for further analysis. Beyond NASA, other space agencies and private companies have also joined the effort. In 2013, the European Space Agency ESA successfully landed the Philae lander on a comet, a remarkable achievement that demonstrated the capabilities of deep space exploration. And in 2015, private company SpaceX, founded by Elon Musk, began successfully launching reusable rockets and plans to send humans to Mars in the coming decades. The last 2 decades have seen an explosion of private companies entering the space industry. Companies like SpaceX, Blue Origin, and Virgin Galactic are developing reusable rockets and spacecraft with the goal of reducing the cost of space travel and expanding humanity's presence beyond Earth. In 2020, SpaceX made history when it became the first private company to launch astronauts into space aboard its Crew Dragon spacecraft, marking the start of a new era in space transportation. The future of space exploration seems boundless. NASA has plans to return astronauts to the moon with the Artemis program, aiming to establish a sustainable presence on the lunar surface by the 2030s. Mars exploration is also high on the agenda, with NASA and private companies like SpaceX working toward crewed missions in the coming decades. Meanwhile, the search for extraterrestrial life continues with missions like the James Webb Space Telescope, which launched in December 2021. The telescope is designed to observe distant galaxies, stars, and planets, providing insights into the potential for life beyond Earth. The history of space exploration is a testament to human curiosity, determination, and the desire to explore the unknown. From the first telescopic observations to the successful landing of rovers on Mars and the upcoming missions to the Moon and beyond, space exploration continues to evolve, pushing the boundaries of what we know about the universe. As technology advances and private companies play a larger role in space exploration, the next chapter in humanity's journey into space promises to be even more exciting and transformative. One thing is certain: the adventure is far from over, and the stars are waiting.